Hello everyone. Today we will be discussing the problem of log root x square minus 3x plus 2 greater than equal to 1. Now to solve such a problem, it is quite very uh, important to understand the base properties, right? That when the base is greater than 1, then we have to but that then we do not have to change the sign of inequality, and when the base is less than 1, then we have to change the sign of inequality. Only on that basis we can solve this whole complete question, right? Although the question is quite lengthy to understand as well as to solve, but let's proceed without wasting any time. So we will the base here is mod x. The base here is mod x. So at first we will take two conditions: when mod x is greater than 1 and when mod x is in between 1 and 0. Now when mod x is greater than 1, we will open the mod x as plus minus x greater than 1. So it will give two cases: when x is greater than 1 and when x is greater than or when minus x is greater than 1. So when x is greater than 1 and multiplying both the sides by minus, we will get x less than minus 1. This is the OR condition, so we will put a union in between these two cases, right? And in this case, again, we will be getting two cases. One, when 0, when mod x will open as x and it will 1, and when the mod x will open as minus x and greater than and less than 1. So to remove the sign from minus, remove the sign from x of minus, we will multiply the whole inequality with minus. Become so it will become 0 minus x minus 1. So here we will having two cases again. There will be or, that means we will have to take the union in between them. So it is minus 1 to minus 1 to 0 union 0 to union sorry union 0 to 1, right? Now this is we have taken, and for this, the first one, it will be minus infinity to minus 1 union 1 to infinity. So we have to take all these two cases. Earlier in the previous video, if you have watched, I have discussed some questions of logarithmic inequality only. If you want to, you can watch it or you can continue watching it, right? Uh, in the previous video, what we have done is that we have taken the bases in two parts, one greater than 1 and one in between 0 and 1, and then solve the inequality, right? When there is a variable base. Now in this case, we will be solving the inequality in the same way, but there will be more cases of the case that we will consider. What I mean to say, there will be sub cases. For example, when we take case number 1, when we are taking case number 1 as mod x greater than 1, in that case, we are having two possibilities. One possibility when x is greater than 1 and one possibility when x is less than minus 1, right? So we have to solve the inequality for both the possible cases. So let's say case 1.1 when x is greater than 1. When x is greater than 1, I can say log mod of x square minus 3x plus 2 greater than equal to 1. Mod x will go there, plus 2 greater than equal to mod x to the power 1. As we have taken x greater than 1, so mod x will open as plus x. Hence x square minus 3x plus 2 greater than equal to x, it will be x square minus 4x plus 2 greater than equal to 0. Now, if x square minus 4x plus 2 is greater than equal to 0, that means we will solve it. So the possible values of x will be, we will use Sridharacharya formula, 4 plus minus under root 16 minus 8 divided by 2. So it will give two values, 2 plus minus root 2 of x. Yes, you can solve it. 4 plus minus under root 8. Under root 8 can be written as 2 root 2. And further simplifying, we can write it as x is equal to 2 plus minus root 2. So we are getting two values of x as it is a quadratic, obviously. So the final answer will be on factorization x 2 minus root 2 minus 2 minus root 2 into x minus 2 plus root 2 greater than equal to 0. So the possible solution will be x is equal to x belongs to the interval minus infinity to 2 minus root 2 union 2 plus root 2 to infinity. Right? Now this is the case for the condition that we have taken. The condition that we have taken here is the condition that we have taken here is x is greater than 1. So while condition we have taken, we have to also take the intersection with the condition. Intersection with the condition x greater than 1. So on taking the intersection with the condition x greater than 1, I can say, or I can firstly plot, here comes 2 minus root 2, then 1, then 2 plus root 2, right? Or just eliminate 1 for once, plus minus plus. This is a general for the case for the sub part. And now if I want to take the intersection, I will include 1. We know that the x must be greater than 1, so the values of x greater than 1, and here these values, here these values. Now the obvious intersection which is being shown is this. That means I can write that for the case 1.1, or I can say that the case 1 subpart 1, the value will be 2 plus root 2 to infinity, right? The answer will be 2 plus root 2 to infinity, will all the possible values of x which will be satisfying this inequality for x greater than 1. Now if x is less than 1, case 1.2, if x is less than 1 but the base is greater than 1, so the sign of inequality will not change. So what can I write here is log mod of x square minus 3x plus 2 greater than equal to 1. So on shifting the base to the other side, I can say the sign of inequality will not change and it will become x square minus 3x plus 2 greater than equal to, but the mod x will open as minus x to the power 1. So x square minus 2x plus 2 greater than equal to 0. If you observe this, the discriminant of this is negative. As the discriminant of this equation is negative 4 minus 8, which is minus 4, right? So the discriminant is negative. That means for all possible values of x, for all possible values of x, y or x square minus 2x plus 2 will be will be greater than 0. Hence, the condition is satisfied. It is automatically satisfied where we do not have to take any values of x. For all values of x, y is always greater than 0, or x square minus 2x plus 2 will always be greater than 0, right? So in this condition, we have this is the this is all values of x, or I can say x belongs to R, right? Now, if x belongs to all the real numbers, we have to take the intersection. We have to take the intersection with this condition. So our final answer will be for case 1.2 will be for answer for case 1.2 answer for case 1.2 will be minus infinity to minus 1. I think this is understood because what I've done is, as x square minus 2x plus 2 is having the discriminant less than 0. So if the discriminant is less than 0, the graph will be of such a manner it will not cut the x-axis, but but for every value of x for every value of x, it will give the value of y. It will give the value of y, and all the values of y will be positive, and that's all which is stated in this inequality. So this is true for all values of x, or we can say, or for all real numbers. And we have to take the intersection with the condition x less than minus 1 and x belong to real numbers. So our intersection will come as the x less than minus 1, which is nothing but x belonging to minus infinity to minus 1, right? This is for case 1. Now we have to solve it. Now we have to solve for case 2. But before solving for case 2, let's combine the answer. Let's combine the answer for case 1 completely. So the answer will be x belonging to minus infinity to minus 1 union 2 plus root 2 union 2 plus root 2 to infinity. This will be our case, right? This will be our answer for case 1. Now, for case 2.1. In the case 2.1, I can say log. Let's first define the condition that base is less than 1 and greater than 0. If base is less than 1 and greater than 0, then as initially mentioned in the above question, in the above solution, that we are having two values when x is in between 0 and 1, and when x is in between 0 and minus 1, or x belongs to 0 comma 1, or x belongs to minus 1 comma 0. So we have to solve the inequality for these two cases individually. So the case 2.1 comes when I am taking, or I am opening the mod x as x, right? Now see, in this case, the mod x value, the base is between 0 to 1, right? So mod x value is from 0 to 1, hence the sign of inequality will change. So sign of inequality will change. So we need to remember this: x square minus 3x plus 2 greater than equal to 1, So when I shift the base to the right hand side of the inequality, the sign of inequality will change and it will become x square minus 3x plus 2 less than equal to x. So it will become x square minus 4x plus 2 less than equal to 0. We have solved this quadratic earlier only, so I can write directly that x belongs to 2 minus root 2 to 2 plus root 2, right? X belongs to 2 minus root 2 to 2 plus root 2. But we have to take the intersection. We have to take the intersection with the condition that we have opted. Intersection with the condition, intersection with the condition that we have opted, that we have opted, which is nothing but x belong to 0 to 1. So let's draw the number line. On drawing the number line, we can plot 0, then we can plot 2 minus root 2, then we can plot 1, and then 2 plus root 2, right? So this is the closed interval to closed interval, then the 0 to 1, 0 and 1. So we can see that the common part or the intersecting part that is coming is this one. Hence, we can write x belongs to 2 minus root 2 to 1. And as x belongs to 2 minus root 2 to 1 will be the answer of our case 2.1. Now, for case 2.2. For case 2.2, I can say that the value of x is from -1 to in between -1 to 0, or this arise because mod x, this arise because mod x value is from 1 to is from 0 to 1, right? So in that case, again, base is between 0 and 1. As the base is in between 0 and 1, the sign will change. The inequality sign will get reversed. As the inequality sign will get reversed, so I can say that as the inequality sign will get reversed, so let's write the inequality log mod x square minus 3x plus 2 greater than equal to 1 and mod x, so x square minus 3x plus 2 greater than equal to mod of x. Now we will open the x as minus of x here. We will open the mod of x as minus of x here, and the sign will reverse. So it will be like this. And on solving, x square minus 2x plus 2 less than equal to 0. Now, if you observe this correctly, then you can see that discriminant of this is less than 0. And if discriminant is less than 0, graph is opening upwards, graph is opening upwards, and the all values of f, for all values of x square minus 2x plus 2 will be greater than 0. But the equation is suggesting that it will be less than 0. Hence, we can say that there will be no solution for this condition. Hence, we can say that there will be no solution for this condition. Right? What I mean is that x square minus 2x plus 2 is less than equal to 0. If you observe, the discriminant is negative. The discriminant is negative as we have seen in the earlier case. In the previous case, it was greater than or equal to 0. So the all values of x, the all real numbers. was the answer for x. But in this case, there is no solution of x that we can that we can arise with. So on taking intersection with the minus 1 comma 0, we will get nothing. So there will be no solution for case 2.2. Hence the answer, hence the answer, the answer for case 2 will be will be as there will is no answer for case 2.2, there is only answer for case 2.1, 2 minus root 2, 2 minus root 2 to 1, right? Now we have solved the answers for case 2 as well as for case 1. So we will be doing the union as we will be doing the union because we are unknown of the fact that what the base is, right? So doing so combining answer, combining answer for case 1 and case 2, we will get we will get 2 minus root 2 1 union. And what was the answer for case 1? Let me see. Uh, it was minus infinite to minus 1, minus infinite, minus infinite to minus 1 union 2 plus root 2 to infinity, right? This was the answer. Let me check it once more. Okay, so this is the answer. Now I can say now I can say that this is the answer after combining the answer for case 1 and case 2. But are we finished yet? The answer is no, because now the most simple part, the domain part is left as we have to calculate the domain. We have to calculate the domain of the inequality, which is x square minus of the argument x square minus through x plus 2 greater than 0. So can be simplified as x minus 2, x minus 1 greater than 0, and on solving 1, 2 plus minus plus. So x belonging to minus infinite to 1 union 2 to infinity. So now we will plot all these points to get a final answer, right? We will be doing the intersection. We will be doing the intersection, the intersection of, we will be doing the intersection of the case 1 and case 2 answers with the domain, with the domain of argument. So what we will get, so let's draw the line. Let's draw the number line. Now minus 1, then it is 2 minus root 2, or okay, 2 minus root 2, then 2 plus root 2, 1, okay, then 1, then 2, then 2 plus root 2. I think we have plotted all the values. 1, 2, 2 minus root 2, 2 plus root 2 minus 1. Yes. Now, uh, Now, firstly, we'll put the values of the case 1, case 2. So minus infinite to minus 1, minus infinite to minus 1, and 2 minus root 2, and 2 minus root 2 to 1. 2 minus root 2 to 1, and 2 plus root 2 to infinity. 2 plus root 2 to infinity, and then domain. Now for domain I can write, for domain I can uh, write minus infinite to 1, minus infinite to 1, and 2 to infinity, and 2 to infinity. So we have to take the common part. So what are the common part here? This is the common part which I can see. One is this part, the another one is this part, and the another one is this part, right? So the value, the final answer for the inequality, for the above inequality, will be x approaching to x belongs to minus infinite to minus 1 union 2 minus root 2 to 1 union 2 plus root 2 to infinity. This will be a final answer. This will be a final answer for the above inequality. So if you like this video, give a thumbs up. That's all for today. My name is Prakhar Jain. Thank you.